Now I want to find the arc length in polar coordinates. So you can see this is really close to we had arc length in parametric equations where we had the derivative with respect to y squared and derivative with respect to x squared. Here I've got r squared and dr d theta squared. All right, so here's r. So let's go find dr d theta. So that's 3e to the 3 theta. So the arc length, you'll always be given where you want to find the arc length from and to. And I'm going to have the square root of r being squared, so e to the 3 theta squared plus 3e to the 3 theta squared d theta. So let's be careful that we work the exponents correctly. So you multiply these two, so I'd get e to the 6 theta, and I'd square the 3, so you get 9, and I multiply the 3 theta and the 2, so I get e to the 6 theta. Okay, so these are like terms. So I get 10 e to the 6 theta. Oops, that's kind of too long there. Okay, like this. All right, so I can separate this as root 10 root e to the 6 theta. So root 10 can come outside the integral. And then if I take the square root of e to the 6 theta, I get e to the 3 theta. And then you know how to take the antiderivative of that. And then root 10 over 3. So now I'm going to plug in the 2 pi, subtract off plugging in the 0. All right. So here are some graphs that we're going to have to get to know. You can use your calculator, but I want you to have an idea of what's going to come up. Remember, anytime you're doing calculus, you must have your calculator in radian mode. If you don't have your calculator in radian mode, you won't get the right graphs. Okay, so if you have r equal a cosine theta, so let's look at r equal 2 cosine theta. Okay, the graph of this will look like this, where it goes out to here, it goes out to 2. So when angle 0 is plugged in, I get 2. When angle pi over 2 is plugged in, I get 0, right? So this had the special quality that it just takes 0 to pi to go all the way around. So this is angle 0, this is angle pi over 2, and this gets me back to angle pi. So if I did 0 to 2 pi, I would go around the graph twice. And I don't want to do that. And so if I'm looking at, say, r equals sine theta, this graph looks like this. So the a in this case is 1, so this would be the number 1. So this would be angle 0, because sine of 0 is 0, so that gives me r equals 0. This would be theta is pi over 2 right here, and then this again would bring me back to this angle of pi would bring me back to 0 again. So these two are equal a cosine and r equal a sine. You have to kind of know that it just takes 0 to pi to go all the way around. This one here, r equal a, doesn't matter what the angle is, you're always going out a distance of a. So if it was r equal 3, then you would have a distance of 3 in all directions. All right, so these 4 cases here are the cardioids. They look like hearts. So let's just do, so when the number a is the same, so let's just do r equal 2 plus 2 sine theta. And let me just kind of show you what happens when I plug in different angles and how to kind of plot some points. So it's going to be important for you to be able to plot some points. So if I plug in angle 0, I get r equal 2, right? Because this goes to 0. If I plug in angle pi over 2, this will give me a 2 plus a 2, so I'll get a number r of 4. Angle pi, that would get me back to 2 again, because sine of pi is 0. 3 pi over 2, that gives me negative 1 from sine of 3 pi over 2, so I'll get 2 minus 2, so that'll go to 0. And then 2 pi will go back to 2 again. Okay, so to draw this, so remember in the polar coordinates you just have a polar axis, but we like to superimpose the xy axis on here. So angle 0, I go out 2. Angle pi over 2, I go out 4. Oh, let me make that. Maybe make my 2 a little smaller, so I have a little bit of a difference showing here. So angle 2, or go at a distance of 2, go at a distance of 4. Angle pi, go at a distance of 2. Angle 3 pi over 2, go at a distance of 0. And back to 2 pi, I'm at 2 again. So because I know it's a cardioid, it's a heart-looking thing that looks like this. So let's do this one. Same kind of numbers. So r equal 2 minus 2 sine theta. So notice the numbers A are the same, right? So it's just necessary, you're expecting a cardioid, so it's nice to know what to expect, and you can just plug in some basic angles like the ones that I just did, right? Pi, 3 pi over 2, 2 pi. So sometimes it just takes a couple of them. I'm just going to go through them all just so you see. So I plug in angle 0, I get 2. Plug in angle pi over 2, I get 0. Pi, I get 2. 3 pi over 2, I would get 4. And 2 pi, I get 2 again. All right, so again, angle 0, I go at a distance of 2. Pi over 2, I'm at 0. At pi, I get 2 again. 3 pi over 2, I'm down here at 4. And back here. So this is the cardioid.